Hello, year sevens. How are you? My name is Miss Nana, and I'm here to take you a lesson on angles. Um, this lesson will be for students in 7x3, 7y3, 7y4, 7y2. I repeat again, this lesson will be appropriate for students in 7x3, 7y3, 7y4, 7y2. Hopefully your teacher should have informed you that this video, will be out for you. For this lesson, it's very important you would need a sheet of paper. Even better, if you have a notebook, that should be ideal. You need a pen and you also need a calculator. Like I said, today's topics will be angles, and we're going to start first of all, how we would normally start our lessons if you were in school. So first of all, you would normally see your 5 a day on the board, which would be your lesson starter. So you have five questions here. You could do the question from easy to anyone you feel will be challenging for you. Any order you feel you can answer the questions, you just have to um, try as much as possible to answer the 5 questions. You have roughly about 5 minutes to do these questions. So I'll put the timer, and then we go. So 5 questions just to refresh your memory, mental skills, things you might have learned in the past. Make an attempt. Make sure you're answering them to the best of your ability. Well done. Okay, well done. I think we can now start to make an attempt on answering the questions now in terms of together. So the first question says, which two lines are parallel? Yes, so you need to remember the keyword, they're parallel, what the keyword parallel actually means. So when two lines are parallel, you're basically saying that there are two lines that never meet. So what two lines are parallel? You would find out that will be line 3 and line 4. Yes? Okay. Now I've taken two other questions that has to do with numbers. So keyword there, prime numbers and square numbers. First one says you need to write down all the prime numbers between 10 and 20. So you need to think back when we did prime numbers. What is a prime number? I can hear you say it. So a prime number will be a number that has two factors, itself and 1. So two factors, itself and 1, right? So if I'm looking for all the prime numbers between 10 and 20, my first prime number between 10 and 20 will be 11, because no other number can fit into 11 except itself and the number 1. 13 would also be a prime number, 17 will be a prime number, 19 will be a prime number. Well done if you got that. Next question says we need to write down all the square numbers between 10 and 50. So you need to think to yourself, what is a square number? So a square number is the result of you multiplying a number by itself. So the result of you multiplying a number by itself. Example, if I did 4 times 4 equals to 16, the square number there is the number 16. Yes, 4 is a square number, and it is a square number because if I multiply 2 by 2, it will give me 16. Okay, right, next number. Harry earns £9 per hour and works for 7 hours. Callie earns £11 per hour and works for 6 hours. Who earns more money and by how much? So what you're simply going to do here is you work out how much Harry will be earning in 7 hours. So you do 9 times 7, that's £63. Callie, 11 times 6, £66. And all you simply need to do is find the difference. Did you get that right? Well done. Next question. Work out 27 multiplied by 254. So here they're testing your multiplication skills, and this is very important. Even up to GCSE level, you would always do questions just like this. So all you're simply doing, there are different methods in which you could use to solve this. Some would actually partition it, multiply, and add them together. But using the basic method of just long multiplication, 254 multiplied by 27. So you do 254 multiplied by 7 first. You write that down. Then you're technically doing 20 multiplied by 254, which gives you this last number here. So all you simply now need to do to get your final answer, add up, and your answer looks like that. Got that? Cool. Well done. Right. Let's go to the lesson straight. So today's lesson is on angles. 3 objectives. One of them, we will recognize the types of angles. Number 2, we will use angle naming conventions. And then number 3, we're going to find missing angles on a straight line and around the point. And at some point, if we're able to, we should be able to find the missing angles in a triangle. Yes? Okay, so keywords, I'm sure you possibly would have learned this in primary school, and this might just be like a refresher for you. So keywords, acute, obtuse, reflex, right angle. A vertex means a corner. Vertices, more than one corner. Right, let's go. How do we make angles? Or what are angles? So angles are created when 2 lines actually meet or they cross. So can you see the examples on your screen? So we have made different angles by just 2 lines meeting or crossing. Yes? Now, when a line meets or it crosses, it's going to form a corner. No doubt about that. Yeah? So when it forms a corner, the key word in maths for that word corner is vertex. Yes, like you can see on the screen, vertex. Now, if it's more than one corner and more than one vertex, I would say it's called vertices. So you're going to change it to V-E-R-T-I-S, I'm sorry, I-C-E-S. Is that okay? Good. Now, angles are measured in degrees. They can also be described according to their size. So the first one we're going to go through will be an acute angle. So acute angle basically means angle that is less than 90 degrees. A right angle, a popular one, a right angle makes a 90-degree angle. Obtuse angle. Obtuse angle is normally between 90 and 180 degrees. So it's more than 90 degrees, but less than 180 degrees. And the last one is a reflex angle. Now, a reflex angle is normally over 180 degrees, but less than 360 degrees. So 4 types of angles you should know. Acute angle, less than 90 degrees. 90-degree angle is a right angle, exactly 90 degrees. Obtuse angle, between 90 degrees and 180 degrees. And reflex angle is normally over 180 degrees and less than 360 degrees. What if we had a straight line? Is there an angle here? Sure, most people will be saying yes. Yes, there is an angle, and that's 180 degrees. Well done if you said that. So a straight line has angles that sums up to 180 degrees, I beg your pardon. So angles on a straight line would normally add up to 180 degrees. Well done. Now, if we had triangles, yes, we can see these angles we have just named. We can see them in these triangles. So if you look here, we have this triangle here, and you can see the 3 corners are made up of acute angles because all the corners there, the 3 vertices, are less than 90 degrees. You could just use that by estimating or just looking at it, that's judging you looking at it. Okay. The next one, obtuse triangles. One angle is more than 90 degrees. Yes. So the top angle here, can you see, is more than 90 degrees. So that's an obtuse triangle. Yes. And obviously a right angle triangle, it has a 90-degree angle. So let's do a quick check on what we've learned so far. So we've learned about acute angles, obtuse angles, reflex angles, and right angles, right? So hopefully everybody remembers an acute angle is normally smaller than 90 degrees. Obtuse angle is between 90 and 180. A reflex angle is more than 180 degrees, but less than 360 degrees. So let's describe the angles we see. So that's one angle there. Hopefully everybody's able to tell me that this angle here is an acute angle. Now, if you notice, that's a protractor, that's a round protractor, but you would normally use the half ones, yes? So definitely, yes, they're normally like round protractors that are like this that you can actually use to measure, but it's not so common. The very common ones are the half ones, the one of 180 degrees, right? Now, I'm not encouraging you to always use a protractor to measure. It's good that you, measure in terms of when they tell you to describe. It's more or less you should be able to estimate, give a rough estimate, right? Because you're going to have some questions where you're told to give an estimate. And then you would also have some questions that can tell you to measure. So they're 2 different things. Well, in this one, we're just estimating. Does that make sense? Cool. Describe the angle. Well done. Hopefully, I'm hoping everyone said obtuse angle. and measuring it, I can see that's 150 degrees. If the protractor wasn't there, you should be able to give a rough estimate. Another one, describe the angle. What kind of angle is that? Good, well done if you said it's a reflex angle. And remember, reflex angle, more than 180 degrees, less than 360 degrees. So well done. Another one. How many degrees would this be? And also, what kind of angle would this be? So you can see by just reading off the scale, 95 degrees, and that is an obtuse angle. What kind of angle would this be? Well done if you said it was a reflex angle, and you can read it there, it's 260 degrees. Okay, and obviously a 90-degree angle, like we said, is a right angle. So let's skip this now and let's go over to giving rough estimates. Yes, so when you're giving rough estimates, because sometimes, like I did mention before, you wouldn't be using a protractor. So the key word there is make an use an estimate. So all you're supposed to do is just basically estimate. Estimate is more or less like a rough guess. Okay. Now, what you can actually use as your guideline is use 90 degrees as more or less kind of your benchmark. So is the angle smaller or larger than 90 degrees? Is it larger? Is it closer to 90 degrees or 180 degrees? Or is it a small angle? It's a smaller angle. So would it be between 0 or 90 degrees? Okay, so I'll give you roughly about 3 minutes now. I want you to look at the angles you see on your screen, and I want you to give me the best estimate for each of the angles you see on your screen from A to F. I'll give you 3 minutes, and then we'll go through the answers together. Okay. 3 minutes is not over yet, but I'm thinking possibly that might be enough. It might be time for us to just go through it together. Okay, so let's look at the first one. Did you get that right? 80 degrees, yes. Very good, well done. Let's look at the second question. So use the guidelines you see on your screen, check it. Is it more than 90 degrees? Yes, so if it's more than 90 degrees, how close is it to 90 degrees? Or how far away is it from 90 degrees? So I'm hoping you gave your answer as 130 degrees, okay? I know a lot of people might be thinking, oh, Miss, why is it not 95 degrees? 90 degrees is just dead on straight. So can you see, I don't think that will be 5 degrees here. So we'll go with 130 degrees. That will be the answer. Okay, next one. We're making a rough guess again. Remember, rough guess estimate, 70, 30, or 110. Well done if you did 30 degrees. That's very correct. Next question, 30, 70, or 130 degrees. So I can see it's less than it's less than 90 degrees. And I can see it's very small away from 90 degrees. It's not up to, say, half of 90 degrees. So I know my answer there would be 70 degrees. So well done if you got that correctly. The next one, I know definitely this is more than 90 degrees and it's just about 180 degrees. So well done if you took the answer. 170 degrees. Well done. And then the final one, if you wrote 10 degrees, then you're correct. Well done. Let's try again. Circle the best estimate. So obviously you wouldn't be able to circle it. So all you're doing is you're writing it down. So first question here, it says you need to still do the same thing. What will be the best estimate for each angle? So we can see the first one, more than 90 degrees, right? And then maybe 10 degrees extra away from 90 degrees. So 10 degrees, no. So it should be 150 degrees, I beg your pardon, because if we made it 100 degrees, that would just be 10 degrees away. So 150 should be ideal. Okay, sorry about that. Okay, next question, 10, 60, or 100. So this will be less than 90 degrees. Well done if you took 60 degrees. Well done. Next question, 80, 90, or 100. 100 degrees, so you're very correct. Well done. Okay, so again, make sure you remember key things, what an angle, an acute angle is. Remember what a right angle is. Remember an obtuse angle. And also you need to remember how a reflex angle actually looks like. So you need to remember that. It's very important. Okay, so I'll give you time, just 1 or 2 minutes. You can fill in the sheet in terms of write it down on your paper. Try and summarize on your own what a acute angle is, what the obtuse angle is, what a reflex angle is, and what a right angle is. So I'll give you another 2 minutes to try as much as possible to jot that down. Well done. Okay, let's go next. So this is what it should look like. Try as much as possible, make sketches, yeah, because this would also help you when you're completing your homework on Hegarty math. So you have an acute angle, right angle, reflex, and obtuse, as I've said. So that's the right answer. Hopefully, I hope you've also done that. If you're not able to do anything, not to worry, the video will still be on Teams for you to access. So you can still at any time still play the video and go through. Is that okay? Okay, here are 4 angles. One question for you to do. Here are 4 angles. Which angles are a right angle? Which angle or angles are a right angle? Which angle or angles are acute? Which angle or angles are obtuse? You need to explain why you chose each angle. Well done. If you were able to choose the first one, P would be a right angle. That's an obvious one. I'm hoping most people would have noticed or understand now that most right angles, you're normally going to find the square at the vertex. So there's like a square to denote that it is a right angle. Although you might not see that in some textbooks the same way, but just know whenever you see a square like that, then you know it's a right angle. An acute angle, hope you came up with the letter Q. Well done. And then you have 2 obtuse angles, and it is R and S. Then obviously if it says you need, if your question is telling you need to explain why you chose each angle, you need to give what you understand by an acute angle, less than 90 degrees. An obtuse angle, it is more than 90 degrees, but less than 180 degrees. Yes, so you should be able to state that down. And there are more questions on estimating the size of an angle. So this also is very important that you understand it. You might not get it spot on, but when you get questions like this in your exams that says estimate, what they would normally do is that they would normally give you an allowance in terms of what the guesses of so it will be like in a range, for instance. So say the answer is really 5 degrees, they might give you a range that we can mark all answers between 3 degrees and maybe 7 degrees, for instance, because obviously we know it's a rough guess. Okay, so double check. So A, B, C, D, and E. Yes, so check it again. If you notice A, a bit further away from 90 degrees. Yes, so you could use that as your guideline. Okay, so because of time, I'm showing the answers here. So if you wrote down your answer, let's say maybe 114 degrees, you're roughly correct. So I'll take one of roughly 2 away and 2 to the right. So 2 to the left, 2 to the right. It could be 2 more or 2 less. Okay, so we're given a rough guess. Right. For each angle, we need to write if it is an acute angle or an obtuse angle. Acute, obtuse, obtuse, and an acute angle. Well done. Okay, now let's move over to the main thing. So we've been able to now know or name the types of angles. We've been able to do that. So let's go into something else. Okay, one of the things that we need to do is we need to know what our angles on the straight lines are and what the sum of angles around the point are. Okay, so let's take, for instance, the robot you see in front of you on your screen. It says this robot needs to turn and walk to the recharge station. You need to estimate how far it needs to turn. So let's try that out. So what could be a rough estimate here? Well done if you came close to 30 degrees. That's very good. Let's try again. The recharge station is there. He's facing this direction. What could be a rough estimate? Well done if you came close, about 60 degrees. Yes, if anything around 60 degrees, you're still correct. Okay, next question. About 110. Yes, because it's past 90 degrees. And if the recharge station was just there, let's see. Oh, wow. He goes 180 degrees turn. Well done. Okay, so if he has already made an angle already, so he's on a 60-degree angle from his starting point already, how much further does the robot need to turn to get to his recharge station? So let's check that out. 120 degrees. Well done. So you would be able to tell me why it's 120 degrees very soon. If it was 80 degrees, how many degrees would he use, or how much further does the robot need to turn? Well done if you said about 100 degrees. You're very correct. So this one wouldn't be a rough guess. This wouldn't be an estimate because we're going somewhere now. Yes, 65 degrees. And his recharge station is just there. Well done if you said it's 115 degrees. Right, so what you would have noticed, obviously, is that the angles on a straight line would normally add up to 180 degrees, based on the way the robot has been turning in terms of how further away he needs to turn to get to the recharge station. Yes, so using that rule, if we know that the sum of angles on a straight line adds up to 180 degrees, if you're given an angle, so for this angle, for instance, is 50 degrees, then that means the remaining angle here, you take it away from 180 degrees, and that's 130 degrees, right? Number two, you do the same thing. So you have 80 degrees there. take it away from 180, you're going to have 100 degrees. Yes? Now, when you're finding the missing angles on a straight line, please don't think you will be using a protractor. You need to be able to work it out. I've only used the protractor there just to basically show you the justification to why it's so, right? But you need to take it away. You need to show you're working out. You wouldn't be using a protractor for this question. Do you understand? Okay. Well done. And well done there. So you're taking all those numbers away from 180 degrees. Now they could even give you more than one angle. So if you notice, that's 30 degrees. Now that angle here, we said whenever we see a square at a corner, then we know it makes a 90-degree angle. Very good. So we need to add 90 and 30 and take away from 180. Then you should have an answer there. Yes? Okay, let's find this one here. You do 40 and 20, that's 60. Take it away from 180 degrees, and you should have your missing angle there. Understood? Well done. Okay, so here are some questions for you to actually do. They're very easy questions. All you're simply doing is you're finding the sum of angles on a straight line, which is 180 degrees. Yes? Okay, so what I'm going to do here is, because of time, I'm just going to show you the answer, but there will be more questions you can do much later on Hegarty Maths and Maths Watch. Okay, so let's look at the first one. A, how do I get A? Take 40 away from 180. And you see your answer. B, you're taking it away from 180. C, you're taking it away from 180. And then D, and you see you have to add those angles together and take away from 180 to get your angle D there. You understand that? Good. Yes? Now, there's something special about this one here. It says this is 50 degrees and it's giving you the same letter, that's E and E. So what would that tell you? Well done. If you said that, that means that the answer on both missing angles will be the same. So that means whatever answer you get here will be the same thing there. So how do I go about it? How would I split the angle into two? So you should be able to do 50, take 50 away from 180 degrees. That will give you 130. Then you need to split 130 into two. You're going to have 65 there and another 65 there. Sorry about that. So this is 65 and the other one there is 65. Okay, now we haven't done angles. Okay, we can still do this even if we don't do angles on a point. So if we look here, we want to find F and we want to find G. Yes? So how do we go about that? What you could do is, can you see this line here? Yeah? All these angles here would add up to 180 degrees. So what I could do is take 58 and 90 away from 180 to give me this angle here. You see that? Now for me to now get this G here, G would also be 58. There's a special angle fact that tells you the vertically opposite angles are always the same. So vertically opposite angles are always the same. So if this is 58, that means the bottom bit there would also be 58. Well done. Now, let's look at the next one now. So we've learned how to find the sum of angles on a straight line. Let's see what happens next. Now, the robot needs to turn to face the recharge station. What are the two commands you could give it? So to the recharge station, the robot can actually turn 90 degrees anti-clockwise to get to the recharge station, or the robot can actually turn 270 degrees clockwise to get to the recharge station. I beg your pardon. Okay, let's see again. This is where the robot is facing. He needs to get to the recharge station. We know that's 180 degrees, so he can go 180 degrees clockwise, or he can actually turn 180 degrees clockwise. So sorry, I beg your pardon. He can turn 180 degrees, first of all, anti-clockwise, and then 180 degrees clockwise. Now you would have noticed something good or something special about the numbers you're seeing. If you double it, it's going to add up to how much? 360 degrees. Same thing here, 120 degrees. He needs to get to the recharge station. He can go anti-clockwise 120 degrees, or he can decide to go 240 degrees clockwise. Add them up, it gives you 360 degrees. Try again. What will be the directions he can actually go to get to the recharge station? He can either go 260 degrees anti-clockwise, or, sorry about that, or he goes 100 degrees clockwise. Add them up, it gives you 360 degrees. Hence, angles around the point would always add up to 360 degrees. How large is the red angle? So let's look at how large the red angle is. If this green angle here was 40 degrees. So establishing what we've just said here, when we add all the angles around the point, it has to give you 360 degrees. So simply, I'm hoping you just do 360, take away 40 degrees, your answer will be 320 degrees. Well done. Next one, how large is the red angle? I know it's not red, yeah, so, but I'm using red. So please assume the missing angle there is red. Okay, same thing, 360 away from 100, and that should give you 260 degrees. Next one, how large is the red angle? Take it away from 360 degrees, and you should have 210 degrees. Easy. How large is the red angle again here? You're just simply taking it away from 360, and then you should get an answer. Yes? Okay. So these questions, again, like I told you, you would be, you can play the video back and you can answer the questions by yourself, but they're very easy questions. So all you're simply doing is you're taking it away from 360 and making sure that the sum of angles around a point, they always add up to 360 degrees. So you must not forget that at all. Is that okay? Well done. Right. Excuse me. Now, let's try out this problem solving or reasoning. I think these questions are very good for you, because when you do questions or when you see questions like this, these are the questions that sometimes they kind of challenge you, you know, in your exam. So that's why I've actually brought these questions out. So look at the first one. This one is kind of similar to what we've done before. So my first example says I need to work out the size of A. So you might be thinking, how do I work out? It shows A. How do I work out A? So you should be able to understand now that the sum of angles on a straight line gives me 180 degrees. So if the letters are the same, so that means the angles will be the same. So the easiest thing you simply need to do is just do 180 divided by 3, and then your answer should be 60 degrees. Can you see that? Easy? Well done. Question 1. What will be D? So again, D showing twice. How would I get those answers? Try it out. Okay, well done. I'm thinking some people would have doubled 123 degrees. So well done if you doubled 123 degrees. You got that answer and you took it away from 360. When you took it away from 360, that answer, what do you do with it? Well done if you divided it by 2. That is beautiful. Well done. So I'm doing 123, add 123, that's 246. Take it away from 360, and I need to now share it into 2 because my letters are the same. Another way you can go about it is just think about this only straight line here. You can think about one of them or any one of them as just a straight line and blank out the remaining half. Yes? so that you did 180 minus 120 degrees will give you that answer. 180 minus 120 degrees would also give you that answer. So that's one way to go about it. Question 2, what will be x? Perfect, well done. If you've done 180 degrees divided by 5 lots of x, that will give you 36 degrees. So yes, your answer is 36 degrees. Well done. Another problem-solving question here. Okay, so I think this will be an ideal question for us to actually finish off. We have roughly about 5 minutes thereabout. So let's see if we can do that. So I want you to make an attempt on that. Mike broke 3 plates into pieces. You need to work out which pieces belongs together. And then you try and make an attempt also on question 4. So definitely you can use a calculator, don't forget. So get your calculator handy and try and use your calculator and get these questions. Let me know if there was a strategy. You can leave me a feedback on Teams in terms of the message area on Teams. Was there a strategy for you to get the answers? Yes. What would have been the easy way for you to actually match the broken plates together? Yes, let me know your thoughts. Okay, let's look at question 4. So question 3 is, I'm sure it's something you can do. Question 4 is still the same thing. I know this is a hexagon, but you don't need to be scared thinking, oh no, I can do this. Think about it. We've learned about angles on a straight line. So look at it. I can see a straight line where the red one meets the black line. Can you see that? A red line makes a black line. So obviously there's a straight line being formed. So I could do 180 minus what? 60 degrees. And that means my H would be 120 degrees. Do you understand that? Well done if you do. So H is 120 degrees. Yes, and if I need to find the sum of angles in my hexagon, that means I need to do 120 plus 120 6 times. So 6 lots of 120 will give me 720 degrees, and that will be my answer. Does it make sense? Well done. Okay, so here it says we need to work out the size of angle A. Don't forget what I told you. I know angles at a point adds up to 360 degrees, but don't make that mistake of saying A and B are the same. They're not the same letters, so they wouldn't be the same answer. So don't make that mistake. Yes, and also using, just by judging, by just looking at it, the size of A doesn't look like the size of B. You can see the size of A is slightly bigger than B. A is an obtuse angle and B is an acute angle. So the answers cannot be the same. So always reason before you answer your questions. So what you can actually do is that this is a straight line, isn't it? This red one, there's a straight line. You can work it out that way. So you can get your A to be 100 degrees. Yes. And then you can also get your B by doing 180 minus 110 to give you that. Yeah, the answer. So your answers should actually, I haven't written down the answer because of time. I'm going to leave you with this question and question 5 for you to do. Yes, so everything, like I said, will be on Teams for you to access. So you can ask any questions so far. just try as much as possible to drop me a few lines on Teams. I'll try as much as possible to answer you as soon as I can. I will be giving you related homework on this Heggerty maths for you to actually do. Well done. Yes, there will be a second part to it because I haven't finished teaching the topic. There's still the angle convention one and the triangle we still have to do, but well done for listening. You've really, really done well. So a quick recap of what we've done today. We've named angles. So you should know the different types of angles and you should be able to identify them: acute, reflex, obtuse, and a right angle. And we've been able to work out the sum of angles on a straight line and the sum of angles around a point. Yes? So I'm leaving you with these 2 questions for you to do. And then next time we will be doing something on angle convention and sum of angles in a triangle. Okay. So that bit now basically tells me my time is up. Well done for listening. You've all done very well. Stay safe, as we always say, and take care. Any questions, please feel free to let me know. Okay? Take care and bye-bye. Thanks for listening.